Given an equation, ax squared plus bx plus c is equal to 0. That's the general equation. If I divide through by the highest coefficient on x, by the coefficient on the highest value of x, I will have, for example, ax squared plus bx plus c divided by a divided by a divided by a is equal to 0. So with this shall give me x squared plus b over a x plus c over a is equal to 0. Now, in general, that's how the quadratic equation looks like. Now, if you want to get the roots, want to attain the roots, then the general formula is defined by the general expression for quadratics is given by x squared minus the sum of the roots times x plus the product of the roots. And this should give us what? 0. So if you compare this equation with x squared plus b over a x plus c over a is equal to 0, this would imply that b over a is always equal to the negative of it is the sum of the roots, while c over a is always the product of the roots. So if you assume, if the roots are assumed to be alpha and beta, then the sum is given by alpha plus beta, and then the product is given by alpha times beta. So for that reason, we can be defining the sum of the roots as negative b over a and product of the roots, which is alpha times beta, as being given by a c over a. So it is from these relationships that now we can design any other aspect that the question might want. For example, they can ask you to find the equation whose roots are perhaps alpha squared and beta squared. It means the sum of these roots is alpha squared plus beta squared, which can be got from, if you recall, alpha plus beta squared. When you expand it, you get alpha squared plus 2 alpha beta plus beta squared. Thus, alpha squared plus beta squared can be attained from alpha plus beta squared minus 2 alpha beta. Then, if I want to get their product, I'll get it from alpha squared times beta squared, which shall give me alpha beta, but now the whole of it is what? Squared. So, the sum of the roots, I'll borrow from alpha plus beta, which I've already identified, and twice of their product. Remember, this is negative b over a squared minus 2 of c over a, and this will give me b squared over a squared minus 2c over a. Hence, likewise, for the product, we shall have c over a, because the product has a times 2, so times 2. So for that reason, the product doesn't have times 2, it just has a square out here. So if it has a square, you square c over a, and you'll get c squared over a squared. Then still, the definition says x squared minus the sum of the roots times x plus the product of the roots should give us what? 0. So we shall have x squared minus, the sum is b squared minus 2c over a over s squared times x plus the product, which is c squared over s squared, is equal to 0. And then we can simplify the equation and go get whatever we want. So when they come in figures form, they will be easier to interpret, like we shall see in the next example. So let's first have this definition taken down. When you get this definition rightly, then you're going to follow the next example.